Hello, hello, guys. If you will take a minute to copy down your vocabulary, there are quite a few words. So go ahead and pause this and then take down your vocab words. Unpause it when you're ready. And then we have a second set of vocabulary words, so please copy those down. Yesterday, we spent some time studying precession and nutation, some of the phenomenons that happen due to the revolution of Earth. Today, we are going to talk about the direct result of the revolution of Earth, which is the seasons. So we are headed to the the doodle notes in your notebook that look like this. This is where we're headed today. We're going to take down all these notes, talk about all these different diagrams, and learn more in depth what causes the phenomenon of seasons. Let's get started, if you will. So warning, a common misconception is that the seasons on Earth are caused by its distance from the sun, but that is not true. Today we learned that the sun is actually closest, or the Earth is actually closest to the sun in January, which we know in the northern hemisphere. That means that we are experiencing winter. So if that were true, that the closer the Earth is, that causes the seasons, that means in January we would be having summer weather, not winter weather. So we know that this is not true. Instead, though, we do know that the seasons are caused by the Earth's tilted axis. So again, with these notes, because I only have a 15-minute time limit, if you will just pause this if you need to and play it when you're ready. So again, a common misconception is that the seasons of the Earth are caused by the distance from the sun. But we know that's actually not true because the sun, or the Earth, is closest to the sun in January. What we do know is that the seasons are caused by the Earth's axis tilt. We learned that the average tilt of the axis is 23.5 degrees from the orbital plane. So instead of standing straight up and down at 0, our axis is tilted just a little bit at 23.5 degrees. Okay, don't worry about the orbits counterclockwise. That's for a later picture and diagram. All right. Imagine, if you will, a flashlight is shining on the surface at different angles of the Earth. Okay, so let's think about a flashlight here. If you have one, you can try this out. So if I have a flashlight and I'm shining it directly at something, we have a more focused area of light. If, though, I tilt my flashlight just a little bit, we have a more spread out area of light, giving us cooler and warmer temperatures. Warmer summers, right? If we are more focused, where it's more spread out, we experience cooler winters. What I want you to remember, and what is very, very important, is that no matter whether my flashlight is straight on or tilted, the same amount of energy or light is being released from the flashlight. That is not changing. That is the same with the sun as it shines onto the Earth. Lots of energy, right? We have lots of energy coming at us from the sunshine. And just to review, the sun creates its energy using the process of fusion, which is when two hydrogen molecules bond together or join to form a helium molecule. The result is a couple of lost neutrons that are shot out into the world, and also lots and lots of energy radiates from this process. That is fusion. That's what happens on the sun. That's how we get our energy here on Earth, that creates the seasons, warms our weather, and powers photosynthesis of our plants. So if fusion didn't happen, we would not exist because we would not have any plants, and it would be ice cold here on Earth. Okay, here is a diagram, the diagram that I hope you will please copy down. I'm not sure why it copied in black and white, but that's what it is. So, if you will, the middle of our diagram is the sun. As always, it's the sun. okay? The Earth is on its orbit. We don't have 4 Earths. This is just showing the different tilts of the Earth based on the orbit of the Sun, or the orbit around the Sun. So we're going to start right here at we are going to start here at the winter solstice for the Northern Hemisphere. We're in the Northern Hemisphere. We're about right here. This is the Earth. You can see our tilt. We're not straight up and down like we would expect. We are tilted, which is what causes this, the seasons. Winter solstice happens when the sun rays are not directly pointed at the Earth. Okay, solstice is actually defined as when the sun is the greatest distance from the equatorial center. Can you see how this is not evenly hitting the equator right here? Most of the sunlight, or the sun's energy, is hitting directly on the southern hemisphere. That is why we're in winter right here, because we are having less of the sun's rays directly hitting us. We're tilted away from it, so we experience winter. When winter solstice happens, when there is, in our winter solstice, we have the most amount of darkness, right? So if we divide our day into 24 hours, 12 and 12 would be even between daylight and darkness. The winter solstice has more hours of darkness than it has summer. It's also known as the shortest day of the year, the longest night of the year. We have a lot of darkness that day. Okay? So the season is caused because the northern hemisphere is tilted away from the sun. So we're experiencing winter. The southern hemisphere down here in like Chile, they are experiencing summer because the rays are more directly focused on that area of the globe. Okay? Now we're going to move as the Earth orbits. So the Earth orbits counterclockwise around the sun. So we're moving that way. We're going to move on to our spring equinox. The sun's rays in the equinox are shining directly on the equator. It happens 2 times a year, and our day is exactly 12 hours, and our night is exactly 12 hours. We have even numbers of sunlight and darkness. Spring equinox. Nothing is tilted towards or away from the sun. Can you see that? Here's our tilt. We're tilted that way. We're not tilted towards the sun. We're not tilted away from the sun. We are in springtime. If we keep orbiting like we orbit, right? We're going around and around and around, and we've now hit our summer solstice, which, if you can guess, if winter we were tilted away, summer we are tilted towards the sun. We have more of the direct sunlight rays hitting the northern hemisphere, therefore it is summer. The southern hemisphere, just like it was in summer right here while we were having winter, the southern hemisphere of Chile, right down there in South America or Australia, they're having their winter. Okay? At summer solstice, we have the longest day of the year, or the most hours of daylight. If we keep going to our very last one, we hit the autumn equinox. As you can see, just like with the spring one, it's not tilted towards the sun, it's not tilted away from the sun, so the sun's rays are hitting directly on the equator. And we are having equal hours of daylight and equal hours of sunlight, or darkness. Okay? The Earth rotates upon a tilted axis. As the Earth orbits the sun, the poles of the Earth are either tilted towards or away from the sun. We just saw that, right? That's what our diagram just showed us. The Earth orbits the sun is an ellipse, not a circle. The amount of energy the sun emits each day is constant. Do not think that the sun increases or decreases the amount of energy that it releases. It releases the same amount each day. Okay? So when we are having summer, it is not because the sun is emitting less energy or more energy than when it is winter. It is just that we are tilted towards the sun in summer. And our last part right here, again, I don't know why it's dark, The North Pole will receive 24 hours of sunlight on the summer solstice. The North Pole will receive 24 hours of sunlight on the solstice. Have you ever seen, and probably Alaska would be the closest you would seen it, they have so many hours of sunlight that they actually have to get special shutters to shut out the sunlight in the winter. Or the summer, sorry, in the summer. So the North Pole received 24 hours of sunlight during the summer solstice. That's a lot of sun. Here we're showing you our tilts right here. If lots of energy, less energy from the sun, right? Less energy, the energy is being spread out more, or more concentrated, less concentrated during the winter. So we're talking the northern hemisphere again. Right here, it is summer in the northern hemisphere because we're tilted towards the sun. We have a very concentrated amount of energy right here. It is winter in the southern hemisphere because we're tilted away from the sun. Therefore, we have less concentrated amounts of energy. If you flip it over here, say we've moved around the sun, we are having more direct rays on the southern hemisphere right here. And we're having less direct rays over here on the northern hemisphere, meaning that it is winter. Okay, that is the last bit of your instructions here on the seasons. I know this was a lot. I'll hopefully find some videos to help supplement what I've been teaching you. Make sure you fill these out, color them, absolutely color these. You at least want the sun and the earth colored, and the flashlight beams. Okay, these are some notes that need color. Have a great day, guys. If you have any questions, please email me. Goodbye.